In this video, we're going to see about GSM channels and its modes. So, in this GSM channel, services offered to users four radio transmission modes, three data mode, and one speech mode. Basically, the radio transmission mode uses the physical channels. So now we are going to see about the different kinds of physical channels and these physical channels are also called as traffic channels. In these traffic channels, we are going to have three different types of physical channel. In that, the first one is TCH slash full F. F means is nothing but your full rate. Uh, this transmits a speech code of 13 kbps or three data mode rates 12, 6 and 3.6 kilobits per second, and whereas we are going to have the second one as TCH slash H. H represents your half rate, so it's quietly the transmission rate will be half of your full rate. It's nothing but your it maintains the speech code of 7 kbps or two data modes. That data modes comes as 6 and 3.6 kbps. And the third one is TCH slash 8, is nothing but the 1/8 of its rate. Use it for low rate signaling channels, common channels and data channels. So these are all the physical channels, and now we are going to look at these logical channels. In these logical channels we are going to have so many types of logical channels. In that, one by one we are going to look at. So now in these common channels there are embedded in different traffic channels. They are grouped by the same cycle, 51 by 8 BP. These BPs represents your burst period. It's nothing but your time slot, which can represent it as, the time slot is nothing but 577 microseconds. And in the downlink common channels, so there are 5 downlink unidirectional channels shared by group by TCH. In that, the first one is FCCH. FCCH repeats once every 51 by 51 by 8 bps, and it is used to identify a beacon frequency. And the second one is nothing but your synchronization channel, which is follows the FCCH slot by 8 bps. And the third one is the broadcast control channel, is broadcast regularly in each cell and received all the mobile stations in the idle mode. And the fourth one is the paging and access grant channel. In this, the access grant channel is answered from the base station and allocates a channel during the access procedure of setting up a call. And the fifth one is nothing but your call broadcast channel. Each cell broadcasts a short message for 2 seconds from the network to the mobile station in idle mode, and it uses in half a downlink. TCH or slash 8 is used, and especially CBCH, nothing but a call broadcast channel design constant exists because of the need for then sending two channels in parallel. So in the next one is nothing but a uplink common channel. The random access channel is the only common uplink channel. RACH is the channel that the mobile station chooses to access the calls. There are two rates, RACHF and RACH slash H. So here also the same thing, RACH slash F represents your full rate, RACH slash H represents your half rate. And and the signaling channels, all the signaling channels have chosen one of the physical channels, and the logical channels names are based on their logical functions. And the next one is nothing but your slow associated control channel. A slow rate TCH used for signaling transport and used for non-urgent procedures, mainly on handover decisions. This combined TCH and SACCH is denoted TACH/F, and this SACCH occupies one time slot in every 26 frames. And the time organization of a TCH as shown in your below figure, in this figure, as you can see here, it will be in a cyclic manner, and here we can see 8 BP cycles with 8 time slots you're going to have. And next one is nothing but your fast associated control channel. Indicates cell establishment, authenticates subscribers or commands a handover. So here you can see here the diagram for your time organization of TSCH/F, and here we're going to have an 8 BP cycle. And the next one is nothing but your standalone control channel. Okay, so it operates at a very low operating at low rate that is enough for the particular SDCCH. And the radio slots are allotted to users only when call penetration is needed. There are two modes, dedicated and ideal mode. The mode depends on the uplink and the downlink. And the last one is nothing but a voice or data channels. And this each time slot of these voice channels contains 260 bits per block, and the entire block contains 316 bits. Each time slot of data channel contains 120 or 240 bits per block. As in these modes are for GSM channel, there will be in three modes, nothing but your channel mode, dedicated mode and ideal mode. Basically in this channel mode, because of the precious value of radio spectrum, individual users cannot have their own TCH at all times. And the dedicated mode, sorry, dedicated mode uses TCH during call establishment and uses SACCH to perform location updating in the dedicated mode. And the TCH and SACCH are dedicated channels for both uplink and downlink channels. Whereas coming to the ideal mode and the last one is nothing but it will be used for the non-call activities. Finally, there have 5 downlink channels are in the ideal mode. Those are nothing but FCCH, SCH, BCCH, which is broadcasting regularly, PAGCH and CBCH, which sends one message every 2 seconds. During ideal mode, the mobile station listens to the common downlink channels and also uses SDCCH to register a mobile location associated with a particular base station to the network. So these are the details about your GSM channels and modes. Thank you.